Hi, everyone. Welcome to Persona Live. Very happy to be here. Today, what we're going to be talking about is wrangling data to multiple places with the project Fluent Bit. I'm one of the open source maintainers and also work at a company called Calyptia that helps build these projects. So today, what we're going to talk about is a little intro to why does wrangling data even matter in the first place? How do you do that with Fluent Bit? What are some of the use cases that wrangling data can be very effective for your business, for your enterprise, for your startup, whatever it may be? And then last but not least, we're going to talk a little bit about advanced use cases and walk through a quick demo. So first, let's talk about why do we even care about wrangling data? So what's that challenge really? What's that problem? The first, I think everyone here would agree that data is just growing at a tremendous rate. And whether or not we want to collect all of it, the truth is it's out there. There are insights to be had. And how do we go about collecting all of that? We have to collect from all these different sources and send to all these different destinations. So every few months, we're seeing there's brand new backends, there's brand new databases, there's brand new places where folks are telling us, hey, if you send us your data, we'll give you the best amount of insights. And so this problem of having so many sources and so many different destinations and so many different ways to get that data in is really a challenge. We don't want to have 1,000 agents on a server. We don't want to have 50,000 agents deployed in Kubernetes just to route data to all of the various destinations. Now, last but not least is formatting. We have just all these different applications, new languages coming up. They all have their different stack traces. They all have their different formats. They all have their different log styles. How do we make sure that we're being effective and catering to that and ensuring that when we're looking at it from an insight perspective, doing analytics on top of it, we're able to get the most information out of all these various formats. So to solve all of these challenges, about 10 years ago, there was a project created called Fluentd, and that ecosystem spurred vendor-neutral open source data collectors. And what that means is they're not tied to a single backend. They're part of a foundation, cloud native computing foundation. So right next to Kubernetes, right next to Prometheus. It's a graduated project. Fluent Bit is part of that ecosystem. It's Apache 2 license. It's deployed 2.4 million times a day. And it really builds off these challenges. One, data is growing. How do we make sure we can grab data from all these sources and send to all these destinations so you can get to your analytics faster? And last but not least, do some formatting, do some processing in between. Now, from a who's using Fluent Bit side, we have a ton of cloud providers that are utilizing it in their cloud, AWS, Google Cloud, Microsoft. A lot of folks are utilizing Fluent Bit in the enterprise today. So you can look at this project as having a lot of maturity, a lot of scale, and something that you can build plugins to. So how does it work? So Fluent Bit is really based off of two big components. One is a plugin system, and the second is tagging. So the plugin system allows us to say there's many sources, so each of these sources can have different inputs, and there's many outputs. So many of these things like, say, Elasticsearch, Grafana Loki, Postgres, Splunk, each of them can have outputs. And as we define routes, we say that one thing is tagged with A, and then Splunk and Elastic will have matching A's assigned to them. Now, these are routed to one or more outputs, and this project of Fluent Bit specifically is written to be very, very performant. It's deployed on embedded systems. It's built for the container age. Here's a small benchmark that we run as part of our integration test suite. For about 10,000 events per second, the CPU here in CPU seconds time is extremely small. From a memory perspective, there's 3.79 megs and 7.48 meg for 10,000 events per second. That's not too bad. So we're really focused on extreme high performance, really high portability, and making sure that you're able to plug in what you need. So let's talk a little bit about the use cases. When you're wrangling data to multiple backends, what does that gain you? Is this just, are we doing this just to send data to multiple locations, or are we doing this to actually solve real problems? And when we look at the latter side, there's really four places that this comes into play, and we'll walk through each of them individually. But the first is reducing costs. I think all of us have gone through this notion of we're collecting more and more data, everything's becoming more and more expensive, but the insights are just not necessarily lining up with that data curve. So, how can we make that more effective? Send data to where it needs to go to maximize that insight curve. Enriching data, getting data and adding context for analytics. We'll walk through a use case of Kubernetes. Unifying the format. How can you do processing? How can you do things that are based off of no specific schema? And then decreasing vendor lock-in. So a lot of vendors will provide agents that are proprietary or open source that only allow you to send data to this specific backend. And the truth is, with backends just continually evolving, when you look at Fluent Bit and wrangling data to multiple locations, you don't want your middle tier to have a preference on where it should send the data. So here, really Fluent Bit being Apache 2, part of the Cloud Native Computing Foundation, that allows you to really make sure you're not taking a reliance on a specific vendor solution. So let's look at the first one, reducing costs. How does this work? So there's a couple ways you can reduce costs. The first, which I think is the most basic, is you are sending data, say on the right-hand side, we're tailing a log and we're sending it to this $, expensive backend. Now what we can do is add a filter. We can just say, let's remove the noise, remove null values, remove empty values, remove values that might contain debug or info logs. Let's get rid of that. The second way is, of course, multiple backends. We're talking about wrangling data here. There are cheaper backends that are available. There's file system storage that's available. And this can be something where I might be a financial institution that needs to archive data for a series of 7 years. I might need to take data and just hold it for compliance reasons from a security side. And so what I can do is I can take that data, I can remove the noise and send it over to the expensive backend, but I can also send a copy to a cheaper backend. I can also use specific pieces in the log to say I want to send error logs to my super fast expensive backend, and I want to send info logs to my cheap backend. And then on top of that, one thing that Fluent Bit offers is really smart snapshotting. This is with our stream processing feature, which we'll talk a little bit about later. But what this allows you to do is say, if I encounter a specific event, don't just send me those 400, 404 events or those error events. Send me it with context. I want to see the path before and I want to see the path after. And that is really awesome when you get into, I want to send snapshots based off certain metric values. I want to send snapshots based off of certain error values. It can really help you reduce noise, but keep context, which is something a lot of times things don't allow you to do. Now let's talk about enriching data. One of the major places that Fluent Bit is deployed is within Kubernetes. And when you deploy within Kubernetes, there's a lot of context that each log should have. The pod, the namespace, the container. These are pieces of information that make it helpful for you when you go to debug. So when you're doing this enrichment, we can do things like look up AWS filters and give you things like, hey, this is the cloud resource, this is the region, this is the AZ. We can use GeoIP lookup. So being able to stream those messages in line, tell you what country, what city you're in case you're part of some certain privacy regulations. And then the last one, of course, we just talked about is the Kubernetes filter. Now, these are things where they're continually evolving. You can enrich with custom data. We have folks who've built plugins that do security lookups for certain IPs to tell whether or not they're malicious. So the really great part here is because this is open source, there's a lot of extensibility here with enriching your data. Now, unifying format. Now, we sort of talked about this in the beginning, but to dive a little bit deeper, one is we want to be able to take all this unstructured data and give it some structure so we can run metrics on top of it. We can uh, perform aggregations. We can send that to a place where it will be indexed correctly and most optimally. And so there, one thing that Fluent Bit includes is a list of parsers like Docker, CRI for the container-based environments, log format, JSON, CSV, things like syslog, TCP, 3164, 5424, all these different various RFCs and formats come out of the box with Fluent Bit, making it very, very simple to just connect in the data source, parse it, and have some level of key value pairs, making that data more useful. Now, if all else fails, you can of course use regex. And we also include Lua filtering. So if you're already using Lua filtering with, say, a web server, you can apply some of those same logic points to Fluent Bit as well. Okay, so let's talk a little bit about SQL Stream Processing. This is really the heavy advanced use cases that come with Fluent Bit. What we did back about 5 or 6 years ago was say, we want to make something very, very lightweight, deployable at the edge. And as folks started deploying Fluent Bit at the edge more and more, what we found is that because we were using so little resources, we could add a decent amount of power in the middle with SQL Stream Processing. So what does this allow you to do? Essentially, within the pipeline that Fluent Bit has, its inputs, its parsers to build that formatting, the filtering to remove data or enrich data, the storage layer and the router, we've added this brand new stream processor, and we use ANSI compliant SQL here. We're not trying to invent a brand new language. I think there's quite enough of uh, query languages out there. So if we can use standard SQL, we can use this to say, let's allow for aggregations, we can build predictions, we can build functions, we can do things like max, min. We'll talk about that in the next slide. The great part about this, no database required. It runs in memory, still very, very performant. So even if you're collecting those thousands of logs per second, we can run those aggregations. And this can be very beneficial when you're trying to wrangle data to multiple backends, because you might not want to send 1,000 metric messages per second. Instead, why don't you aggregate that to one message per second that just includes all the details, the summary, the average. The other big part about this is schemaless. So we don't require any format. We don't require you to have XYZ. We're just going to take in the format that you've brought in and try to operate on top of that. So some use cases that come with the stream processing, and we're going to demo a bit of this in a little bit. The first is aggregating and routing data effectively. So again, summarize those events before sending. You can use max, min, average, sum. Sending events only that matter. Talked about this a little bit, where you can send data with context using the snapshot parameter. Time series predictions. So Fluent Bit does offer some time series prediction capabilities where you can say, let me predict out to the next 10 seconds. And then alert faster. So if we find that CPU or memory or some derivative metric derived from a log is triggering at some level, we can alert directly to an output like Slack. We can send a message to Splunk. We can send a message to Elasticsearch or Loki, to Postgres. We can do all sorts of really fun things when we're doing a little bit of this analysis at the edge layer from a stream processing side. Now, this is not meant to replace your backend analytics by any means, but instead be an augmentation where you can say, instead of having to run these alerts and cause this havoc in processing power, or I'm trying to do some schema on read, schema on write type operations in my pipelines, why don't I bring some of that logic at a distributed layer? So instead of centralized in your backend analytics, why don't we distribute that across thousands and thousands of edges, your pods, your nodes, your Kubernetes nodes, things that are ephemeral, that are growing, that are distributed, and add a little bit of load for each of them. So, the same benefits that we see from a cloud computing side of going distributed, we're trying to bring that to the analytics space here. Again, not a replacement, but something that can really augment your entire pipeline here. Now, something I'm very excited for here is some new features that are coming out. And this is really a place where we've been investing to make sure that this process is a little easier and can benefit the entire Fluent Bit community. The first is dynamic stream processing. So being able to say dynamically switch my endpoint from one backend to the next. You can imagine using perhaps a bill trigger, an alert on a certain cost threshold to say switch my backend from very expensive backend to very cheap block storage. And this is something that's configurable via an HTTP endpoint. You can view, list, and create stream process tasks. For example, on the right, we have what a stream process task in Fluent Bit looks like. And then from a live query perspective, we can actually flush that data directly to the lens of what we're operating on. So we're able to very quickly go ahead and see what does live data look like and how do we most effectively bring this to a place that's going to be really useful for us. So with that, let's go ahead and switch into a quick demo. We're going to look at live stream processing and creating some dynamic stream processing jobs. Okay, so what we're going to go ahead and do now is we're going to look at some live stream processing. And so what we're going to be doing here is we're going to tell Fluent Bit to go ahead and add a stream processing task, which will take in some data, and then we're going to live query that data. Now, the cool part here is when we're tailing a live log file, so we're looking at var log messages. I have three windows open. So the second window I have here is really just another window where I can run logger, so we can create some test messages. You can see that it just popped up here. And then the last one is I have my local laptop. So this server is running in the cloud, so I'm going to actually be performing all these stream processing and live query jobs remotely, so not on the same machine it is right now. So let's go ahead and first look at the active tasks that are part of Fluent Bit right now. So in order to do that, we're going to first grab the curl query. So here I have the list tasks. I'm going to go ahead and just look at what that looks like. I'm going to go ahead and grab that curl command. I'm going to remove the verbose piece. And we're going to switch this from localhost to my server, which is perftest.fluentbit.io. And we can see it's empty. So we don't really have anything in there as of yet. But let's go ahead and look at the query that we want to add. So here, we're going to look at Snapshot Query. And if we look at this, you can see I have a task name defined called live query. The second is the Sql statement. So I create snapshot, tail snapshot, and I'm doing this with a bulk of 5 seconds with the tag tail snapshot, which will be used for routing. So in case I have another event that only matches tail snapshot, and I'm going to select every single piece of that record that has the initial tag of tail. The other piece that I've added on here is I'm limiting this to 5 records. Because we're doing a live query, I'm not too interested in getting all the data. I'm just interested in getting a preview of that data. So let's go ahead and quit. And we're going to now look at the create task. So here we're going to make a post command where we'll switch that localhost over, and we're using the snapshot query as the data. So let's copy that here. And we're going to switch localhost. Okay, looks like we got a 201 created. Let's go ahead and list that again. So run the same command again. And here we can see that our stream process task is now listed. So we have that available to us. Now let's go ahead and run the live query. So here's the live query. We're going to go ahead and grab that. We're going to go ahead and, again, switch our endpoint here to perftest.fluentbit.io. Now, if I go back really quickly, there might have been a couple messages since my high, but let's look just in case. My guess is this will be empty. Okay, so here we don't really have anything. It looks like it is still pretty empty. So what we're going to go ahead and do is create a couple of logger messages. So hi1, hi2, hi3, hi4. Let's look if those appeared here. We're going to go ahead and run this now here. And we can see that we now have this JSON record that hi1, hi2, hi3, hi4. Now, if I was to run this again, because it's flushed the context, I would actually just get a empty message. So that's what shows up right here. So what this lets you do is, for example, go ahead and create dynamic stream processing tasks, which could be something as simple as what I've done here, which is select everything, limit those messages to 5, to something much more advanced like create the average or switch to the average once we are below a threshold, or if we're above a threshold, keep sending all the most relevant data, and then we can live query that data. Now I'm querying this just with my curl command, but I think as everyone here would be able to attest to, you can imagine the power of being able to query this via remote APIs, via automation, and really plug this into your entire data pipeline. So with that, I'm going to go ahead and stop sharing. So for those who are interested in additional stream processing type functionality or stream processing hands-on activities, I have in the slide deck attached a GitHub repo that includes 4 examples. Those 4 examples will walk through very basic stream processing, some advanced stream processing, some group bys, some max, some min, some average, and as well as a time series prediction. So it serves as a really nice basis. So anyways, thank you all for giving me the opportunity to speak. I do hope that you'll be able to join us on the Fluent community at slack.fluentd.org. Participate within any of our community events and give us feedback. We're always looking to improve the projects and build a better ecosystem for our users. So with that, thank you so much and have a good one.